Welcome back to the second of 4 presentations where we discuss project formulation and evaluation using risk assessments. I'm Chris Dunn, Director of HEC. In this presentation, we will describe the plan formulation and evaluation strategy. In the previous presentation, we provided an overview of the SMART planning process. In this presentation, we'll describe the formulation and evaluation strategy. And in the next presentation, we'll identify the without project condition, understand the analysis perspective of the flood risk management measures. And then in the last presentation, we'll talk about compiling, displaying, and interpreting results. If you're familiar with the core planning process, you've seen this figure before. This planning beehive, as I like to call it, really represents the 6 steps in the planning process. In the SMART planning process, you use this beehive or these 6 steps over and over again through the scoping process, through the selection of the tentatively selected plan, through the feasibility study. Step 1 is you specify problems and opportunities. Step 2, you inventory and forecast your conditions. Step 3, you formulate your alternative plans. Step 4, you evaluate the effects of these alternative plans. Step 5 is you compare the alternative plans. And step 6 is you select the recommended plan. We're going to talk about each of these in detail as we go through this presentation. Scoping analysis. In the SMART planning process, which we discussed earlier, it is clear that we do not perform a detailed risk assessment for each alternative at the beginning of a study. We have to perform some shortcuts. Therefore, the following may not be included. You may not have detailed cost information. You might not have detailed engineering design or a detailed environmental assessments. You won't be doing optimization and benefit cost analysis, and you're likely not to have detailed real estate information. So you have to ask yourself, what are my primary risk drivers, and what is causing my uncertainties in my results? And do they have a significant impact on the results? So let's discuss the planning process itself and the formulation strategy. Step 1 of the 6-step planning process is you specify your problems and your opportunities. A problem could be there's flood damage to the city. An opportunity could be, well, there's also loss of fish habitat, or there's stream bank erosion that I need to address. Next, you inventory and forecast the conditions in your without project plan. So you need to determine the without project conditions, both for your base year, which is the year that a project would go online, and the most likely future year with uncertainties, and you need to determine the magnitude, location, and type of damage and performance indices. So this quantifies the resources now and in the future in the absence of a plan. So that means you're not putting in a reservoir, you're not putting in a levee, you're not raising a levee. These are the conditions that exist today. It is the most important step in the planning process because it is the baseline from which all alternatives are compared. So if you get this wrong, the rest of your study is going to be wrong because you're going to compare all your alternatives to this baseline condition. So you need to spend time and get the baseline condition correct, both for your base year and for a most likely future year, which we'll talk about in a little bit more detail. Step 3 is you formulate your alternative plans. This is your with project plans. So an alternative plan consists of a system of structural and/or non-structural measures, strategies, or programs formulated to reduce flood risk. So what are structural measures? Structural measures are like levees or reservoirs that actually modify the flood or change how frequently an area might get wet. A non-structural measure are measures that modify the damage susceptibility, but they don't change the frequency that an area would get wet. So that could be raising a structure or moving structures out of harm's way. Both of those would modify your damages, but it wouldn't change how often that area gets wet. So a full range of alternatives are identified, screened, and refined in subsequent iterations throughout the planning process. So step 4 is you evaluate the effects of your alternative plans. You develop basic formulation and evaluation data. You quantify your uncertainty in your flow, stage, economics, and life loss. You nominate your alternatives, your acceptable solutions, and you perform the Monte Carlo simulation for your analysis. So it's clear you do not just jump in and perform a risk assessment on every alternative that is formulated. You want to refine the list, figure out which alternatives you're going to move forward with, and then you're going to start doing detailed uncertainty analysis and perform your Monte Carlo analysis on those plans. Step 5 is you compare your alternative plans through an array of evaluation results. And then step 6 is you select a recommended plan from a flood risk management perspective. It doesn't have to be the NED plan. It can be a different plan, but you do need to develop your performance metrics for the NED plan as well as any other alternative that you're going to move forward with. So what are the metrics that you have to develop? You have to develop your economic metrics. These are required for the analysis for all final alternatives and the NED plan. So you have to compute your expected annual damages. You have to compute your equivalent annual damages. You have to compute the distribution of your expected annual damages. Okay, all these we talked about in the previous presentations. So also you have to develop your performance indices, and you have to be able to determine whether you're providing safe and predictable protection. So you have to answer this question: how will my project work perform for a range of events and conditions over the project life? It's not just how will it perform for one particular event, but how will it perform across all the events, even the events that exceed the design. So you need to know that you're providing predictable protection. So the performance indices, we've talked about these previously. Annual exceedance probability, or the likelihood that you're going to get wet in any given year across the full range of events and including project performance. The long-term exceedance probability, the likelihood that you're going to get wet from a 10, 30, or 50-year time period, once or even more than once. Your assurance, or formerly called conditional non-exceedance probability, is the ability of your project to protect you from a particular event, both probabilistic or historic event. You need to compute that. And then you need to determine the consequence of capacity exceedance or your residual risk. What would happen when and if your project gets exceeded? You still need to know that. So risk is a function of the probability of the event, the probability of exceedance or failure of your project, and the consequences if the project were to be exceeded. So it's really a measure of the probability and severity of an adverse effect to life, health, property, or the environment. So your formulation strategy for your NED plan is defined in your principles and guidelines in Chapter 2 and also incorporated in the ER Engineer Regulation 1105-2-100 or the Planning Guidance Notebook. In there, it says your period of analysis for comparing costs and benefits shall be the lesser of the period of time of any alternative plan would have effects. So when is it still deriving benefits? Not to exceed 50 years, except for major multipurpose reservoirs. So levees would be 50 years. And then for reservoirs, major multipurpose reservoirs, not to exceed 100 years for those particular projects. So all your alternatives would have to be compared across that 50-year or 100-year time window. And NED benefits and costs must be compared at a common point in time. So what does that mean? So we've talked before about expected annual damages, but now we also have to talk about what are called equivalent annual damages. So you need to compute your with and without project future conditions for most likely period of time, a 20 or 30-year time window out from the base conditions. So what that means is that you are going to compute your expected annual damages for your base year. In this figure, that's 2024. That's the first year that a project's going to start to derive benefits. The base year is not your existing conditions. It's not your current conditions. Your base year is the year that your project first derives benefits. So it needs to be constructed. So then you also need to compute your expected annual damages at your most likely future year, or MLFY. In this figure, that's 2054. So you need to make a prediction about what your situation is going to look like in 2054 or at that most likely future year. And then because your period of analysis is 50 years, what FDA does is it takes the most likely future year and then draws a straight line across to the end of your period analysis and computes your expected annual damages for each one of those years between your most likely future year and the end of your period of analysis. You determine your project and discount rate using the economic guidance memorandums that come out multiple times a year to perform your equivalent annual damage analysis. And again, FDA will compute not only your expected annual damages at 2024, your expected annual damages at 2054, and your expected annual damages at 2074, but it also wraps that up and computes your equivalent annual damages as well. So in addition to computing your damages at a common point in time, you have to compute your damages using a consistent damage reaches across all plans. And so when you're developing your damage reaches, you must take into account that the damage results are consistent across all the plans. Damage reaches are defined and delineated using this following guidance. So first, you want your damage reaches to have consistent frequency curves. So looking at this figure and seeing these different damage reaches, you can see that you have 2 up in tributary areas, and then you have 3 damage reaches down below, below the confluence of those tributaries. So you want your damage reaches where you have consistent frequency curves. Clearly, the damage reaches in the tributaries will have a different frequency curve than the damage reaches below the confluence of those tributaries. So you delineate your damage reaches where you have consistent frequency curves. Subbasin delineations is another area where you would have different damage reaches. You would have a damage reach at stream gauges. You would have damage reaches at projection or project locations. You would have damage reaches delineated based on jurisdictional boundaries, and you would have damage reaches delineated in other areas where you would want to report various conditions. So your project has to be divided up in a common time, and your project has to be divided up into common space. So what we talked about here is the plan formulation and evaluation process, and ultimately what you're going to get is you're going to get discharge probability relationships or flow frequency relationships for each damage reach, as we just discussed in the previous slide. You're going to get stage discharge relationships at each of those damage reaches. You're going to get stage damage relationships with their uncertainties at each one of these damage reaches. So the discharge probability relationship is going to be computed by your hydrology folks. The stage damage relationship or your economic relationship is going to be developed by your economists, and your stage discharge relationship is going to be developed by your hydraulic engineers. Once you have these 3 relationships, once you have the uncertainties about these 3 relationships, then the Monte Carlo process and FDA can be used to compute your damages, both your expected annual damages and your equivalent annual damages and the distributions about those damages. So we have completed the second of 4 presentations in this series introducing you to project formulation and evaluation using risk assessments. In this presentation, we described the formulation and evaluation strategy of the SMART planning process. Now would be a great time to capture any questions you have on this session, and we can discuss them in our next discussion session. Next, please join me in the third of our 4 presentations. See you then.